All right, we're going to dive into one of the most intense situations you can face in an engine room, an auxiliary engine failure while you're maneuvering. Now, this isn't just about the technical steps, it's about building a mental framework for any junior engineer who's staring down a crisis. We're leaning on the real-world experience of Chief Engineer Daniel G. Tilioka to show you exactly how to keep your cool and be effective when everything is on the line.
And trust me, that is no exaggeration. The second that breaker opens, it stops being just a technical issue. The entire sound of the engine room changes. Alarms start screaming, and you can literally feel this wave of tension shoot from the engine control room all the way up to the bridge. Suddenly, it's a ship-wide crisis where every single second counts.
So, what makes this moment so critical? Well, think about it. When you're maneuvering, coming into port, squeezing through a narrow channel, there is zero room for error. Out on the open sea, you've got all the time and space in the world. But here, your main source of control isn't even the main engine anymore. It's all about having stable, reliable electrical power.
Now, this table really shows you why maneuvering puts such a unique stress on your power plant. Just look at the bow thruster. It hits the system with a sudden, massive load. See, it's not like the steady, predictable load you have at sea. Maneuvering is all about these sharp, aggressive power spikes. The steering gear, the thrusters, they're all hammering the system, making it incredibly vulnerable to instability.
Okay, so let's walk into the moment it actually happens. You're on watch, everything looks good. Temps are stable, the load sharing is perfect, the vibe is alert, but it's routine. And then, with just one sharp click of a breaker opening, your entire world flips from calm to crisis in less than a second.
That sound? It's not just about one generator stopping. It's the sound of your entire electrical grid getting thrown into absolute chaos. It's like the ship's heartbeat just skipped a beat, and every single person in the engine room feels it. The entire support network that keeps the ship under control is now on shaky ground.
And the dominoes start falling immediately. The generators still online are suddenly hit with all that extra load. Voltage and frequency dip, which could trip other sensitive equipment. You'll hear alarms going off for non-essential systems as the ship automatically sheds load to save the important stuff. But here's the bottom line. You are now running with zero backup. One more tiny fault and you are staring at a full blackout.
And this is the perfect way to picture the psychological storm that's hitting you, the junior engineer. You've got intense time pressure to figure out what's wrong. You've got consequence pressure, where one wrong move could cause a blackout. And you've got communication pressure, because the bridge needs clear, confident answers, not, I think so. This trifecta is exactly what can lead to panicked, dangerous mistakes.
This brings us to the single most important part of your response, that first minute after the trip. This is where professionals are made. Your gut, your instinct, is going to be screaming at you, just find the reset button, start it back up. But you have to let your training and your discipline override that instinct.
This right here, this is the mental switch you have to flip. An amateur panics and asks, how fast can I get it back online? A professional takes a breath and asks, why did it go offline in the first place, and what could happen if I try to restart it without knowing the cause? That second question is what prevents a single trip from becoming a catastrophic blackout.
So what does that professional response actually look like? Well, first things first, stabilize what you still have running. Look at your other generators. Are they handling the load? If they're stable, you've bought yourself some time. Next, verify the condition of your switchboard. Are the voltage and frequency steady? Only then do you communicate, and only then do you start hunting for the root cause, all while making sure you're protecting against that second failure.
And your communication has to be crystal clear. Look at the difference here. On the left, you've got a report that creates panic and uncertainty. We had some kind of trip, we're checking, but on the right, you have a professional who builds confidence. Number 2 generator tripped. Remaining units are stable. Redundancy reduced. Stand by for update in 3 minutes. One is guesswork, the other is operational clarity.
Now let's get into finding that root cause. Here's something really important to remember. Maneuvering doesn't create failures, it exposes them. The intense, spiky loads are like a stress test for your entire system, and they reveal the hidden weaknesses that were just lurking beneath the surface during that smooth, steady sailing out at sea.
And these are your usual suspects, the ghosts in the machine. Things like a tiny bit of air sneaking into a fuel line, a seawater cooler that's just a little bit fouled up, or governors that just can't agree on how to share the load when things get crazy.
And you know, a lot of the time, the culprit is a recent maintenance job where a setting was left just a little bit off. Your job is to become a detective and find that hidden weakness.
So finding the cause is absolutely crucial. But, and this is for the senior engineers watching, these moments are way more than just emergencies. They are powerful, unforgettable teaching moments. How a chief or a second engineer guides the team through the chaos is just as important as how they manage the actual machinery.
You see, a great leader doesn't just bark orders. They ask questions that force their team to think critically. Was there a warning sign we missed? Was our standby equipment actually ready to go, or did we just assume? Could this same problem take out our other engines? These are the kinds of questions that turn a junior engineer who just reacts into a proactive engineer who thinks.
At the end of the day, the best way to handle a blackout is to make sure it never happens in the first place. Your best defense is a proactive, almost obsessive mindset that kicks in long before that pilot ladder ever goes over the side.
And this is your actionable checklist, your pre-game plan. Don't just assume the standby generator is good to go. Prove it. Do a quick review of any recent work done on the electrical or fuel systems. And this one is huge. Talk to the bridge. If you know they're about to slam the bow thruster to 100%, you can prepare the plant for that hit.
Because here's the thing, no plant is ever perfect. There will always be some hidden vulnerability. So real success isn't about avoiding failure completely. It's defined by the discipline, the judgment, and the teamwork your crew shows when that inevitable instability hits. That is the real test of a good engine room.
This, right here, is the ultimate takeaway. This is the line you need to remember. See, anyone can push a reset button. A true professional understands that their job is so much bigger. It's about restoring stability to the machinery, yes, but also restoring operational capability to the vessel and restoring confidence to the entire crew.
And that's the last thought I really want to leave you with. Getting that engine back online is only half the job. The other half, the harder half, is managing the human element. Is your team calm? Does the bridge have faith in the engine room again? Restoring that confidence. That is the mark of true leadership and real competence in a crisis.